Welcome. In this video we're going to look how you can troubleshoot any electronics device that has problems or faults. When you talk about troubleshooting, it means all steps or procedures used in finding problems of device and how can fix or getting the solution of that problem. So we're going to see all steps and the procedures used in troubleshooting of electronics devices like a subwoofer, computers, televisions and the other electronics device. So we're going to troubleshoot this subwoofer so as you can be able to troubleshoot other subwoofers. In troubleshooting, normally we start with easiest and fastest steps and we are going to end up with longest and hard steps. So we have 12 steps that you can use in troubleshooting. So we're going to study all steps. We can group all troubleshooting steps into two groups. First group contain 3 steps which done before opening or to unscrew your electronics device. It means can be carried out of your device. In the second groups are those procedural steps that done after open your device or done inside of device. So we're going to start with procedures that you can carry before open the device. The first steps is to get user informations or user details. From this step it means you are going to ask a particular user of the device about the problems of the device and how the device fall in those problems. So when you have user details will help you to know the locations of the particular problems and you will go directly to correct it at a very short of time. Also it reduces the number of procedures of troubleshooting to be carried out, so the responsive user will be according to the problems of the device. Have example, my subwoofer has no bass sound or my television does not show any signals or pictures. So it depends on kind of device. In case of this of subwoofer here, it has no sound, bass sound and tweeter sound, or I can say no sound come from this subwoofer. So this information gave me prediction that the faults will be on speaker or amplifier and so on. We're going on step number 2, which is to confirm the presence of problems on your device. So you must make sure that you confirm the device has problems there, because user information sometimes cannot be enough to give you clear picture or directions where to focus on. When your troubleshooting can help you to go direct and to predict more where the problem is. So you must confirm by turn on your device and see how it works and how the problem is. Let's also turn on this and see how it works. As you see, no any sound that come out after turning on this device. That is how you can confirm the presence of the problems of the device. Now we're going to carry out step number 3, which is to make inspection in the main cables or plug cord. I mean the cable take power from socket or extension to the device like this cable here. This step is very important, especially for electronics device that does not turn. I mean no any signal come out after turn on. So it is very important to carry out visual inspection on plug for any covering like rust. Check physical and isolation damage of the cable. Some kind of main cable like this has fuse, so check continuity of the fuse and all terminals. I mean phase, neutral and earth terminal of cable source to prove that the cable is working by using multimeter. If you suspect any damage, fixed it and try to power it to see if problem has been solved. This step number 4 is the last step of the troubleshooting before opening your device. So now we're going to see steps done after open or carried inside of the device that will help us to identify particular faults present in our subwoofer. After getting inside the device, first things to do is to clean up, to remove all dust and the spider web and all unwanted things, so as to make all components in your PCB to look clean and visible. To help you to read components very easy, but in this case is clean and other things, is to determine all parts and all wires present in devices and to know where they are coming from and where they are going. Like in our case here, we have this cable for input home power supply that come up to this switch here and they get into the PCB of this connector. This one is another kind of power supply which is DC 12 volts from solar or another sources and pass through this bridge rectifier, then get into PCB. This wire is for antenna as you see antenna's diagram. These all wires come from display to the PCB, connect PCB and display. These here connected to base speaker. And this is our main PCB, the connect all load and main display and all speakers. Let's continue with step number 4, which to check the input powers that go to the load source. The load can be able to function. In case of this subwoofer we have two load, which are display and speaker, so we are required to check all load if they have the required power to make them to function. Like in this case of subwoofer here on sound provided after turn on, so either no signal or power reach to the speakers or speakers have some faults. So first you can remove load connection. This here is for display. These here are for base speaker. And the tweeter speakers are connected here, so we're going to check all signal required by loads. In checking the power required by loads you can use multimeter or load equivalent to the one you check, and there's more efficiency when you use other equivalent load which is working good, because sometimes multimeter can be difficult to use. It depends on device you have. We are going to use multimeter to check all power needed by loads, and you have to know range of power required by each load so as to check confirm that amount. Like in this subwoofer display and loads can work between 5 to 9 volts. Let's start with powers that go to the display. Here this one is good amount that's supplied to the display, that is why display turn on. Let's look on base terminals here if have power also. Wires from base speaker is connected here. The connector is very loose, it shake, we must to fix it. No power reach here. It means this base connector is connected here on backside. As we see no power here that can make bass to give sound, that is why no bass in this device. And this white wire is ground, which connected to this big trace. And this is positive terminal. It's connected here. Let's prove by checking continuity. So positive terminal of base connected here, so let's check power between positive and negative terminal. This proved no signal or power for base to function. Now let's check also the power required by tweeter speakers here. These two holes for output where tweeter is connected. And these are for input, so let's check output here. No any power for tweeter to function. Let's try to check at these connectors because tweeter is connected here, as you see no power also. We have done with this step number 4. We have seen that no any power supplied by this PCB to the speakers, so as speakers can give sound, we can conclude that subwoofer has no sound because no power reached to the speaker, so we're going to check the cause of this in next steps. Step number 5 is to check functionality of loads. If is good or bad. We have two main loads in subwoofer, which are display and speakers. In case of display, we have seen that display get power and it function good, but in case of speakers, no power reach to speaker. This make them no function, so the problem is not on speaker. I will not test them now. I will test them in case the power reach to them but still not function. The fault is on PCB, so we're going to carry troubleshooting with PCB and see all possible indicators that can be used in identifying and locating faults on PCB. Let's learn all things to make you know where is fault in PCB. Let's continue with step number 6. Step number 6 is make a visual inspection on your PCB. Visual inspection, it means by using eyes we concentrate on looking at all possible damage that can be observed by eyes on PCB. Firstly, let us identify all components in this PCB. Home power supply input connector. 4 diodes form bridge rectifier. Capacitor, which is JNC capacitor. Optocoupler. County Route 5228 MOSFET. TL431A regulator. Step-down transformer. Diode for half rectification. 5 volts regulator. Capacitors. Input and output ports. These are heat sink used for cooling amplifiers. So as amplifiers can work at required temperature. This is amplifier for amplify bass signal. And this amplifier is for amplification of tweeter signals. Display connector. After identify components, let's continue. So we are going to check present of damage like heat mark, burn mark, smoke coating on PCB. Smoke coating and burn mark like this here on PCB as you see is light black smoke coating, so if damage like this has observed you must check if this cause of problem or not and fixed if this component is SMD resistor you can try to measure and to check if it's not the one that need the device to fail in operation. Let's put multimeter in resistance mode and measure this SMD resistor. The resistor is good. Try to check also continuity of traces where this SMD is connected to other components. So the resistor has no any fault. Okay, let's continue with this step now. Look on present of any loose connection, any shaking components. And look any missing components. Sometimes component can fall down due to vibrations or short circuit that can melt the solders and lead the component to fall down. Also make inspection of traces on PCB. Trace can damage due to burn effect, bruised, scratching or overlapping. Check also presence of short circuit because sometimes components can short like IC pins due to very close each other, and also SMD capacitor can get short. Hammer these things to look at bad soldering or incorrect soldering. And also check blown components like bulging capacitor and missing or breaking blown of IC. Full visual inspection of this step number 6. All components are good, no damage observed. Let's jump to step number 7, which involved making diode mode check in semiconductors components and continuity check. By using diode or continuity mode of multimeter. Use diode mode to test voltage drop of semiconductor devices like diode transistors, red diode, triac dioc and bridge rectifier. Make continuity test of some traces and wires that you suspect to have faults. Also make continuity in fuse and transformer present in PCB. Use continuity mode to check for short and ground faults, and especially in very closed components, traces, solder and IC pins. Let's check voltage drop of this SMD diode. Multimeter read 0.561 voltage drops in forward bias. To test diode if it's bad or good, it must give range of 0.2 to 0.7 voltage drops in forward bias, and it must read over limit in reverse bias. This diode is good. This also is good. This one here is good. Let's check also the continuity of this base connected to the amplifier pins. This terminal is good. Let's check on other terminal. This is good also. This connector must be fixed but is not source of faults in this subwoofer. Let's check short circuit here. Not short here. We have done with this step number 7. No faults observed. Now let's move to the next step, which is step number 8. This step depends on your PCB. If your PCB contain components like LED diode, display motor, even buzz, or any component that can indicate that there is voltage flow across it. This step required you to supply power. You must know the amount of power of a particular PCB to work and then supply it. After supply power, check on the PCB if LED diode comes on, if display present on comes on. So this will make you to know flow of current on PCB, and where current reaches the event of LED diode and display to comes on, make no flow of current. It depends on particular PCB if it has components to show the flow of voltage. But in this case my PCB here, it has no LED diode or display, so nothing to note about flow current on this PCB. Let us proceed with step number 90. This step requires to supply power and to check the power supply block. A lot of this device use linear power supply system. I mean this system has few components, which are transformer, bridge, rectifier, diode, capacitors and regulators. So after power, the PCB measure voltage flow across transformer, regulators, rectifier, diode, capacitors. If is 1 that is required. In this PCB we can see power, which is 230 voltage, get into PCB through these 2 pins, then pass across this bridge rectifier. Other AC voltage pass across step down transformer. Then in this diode. Then in capacitor, and then in this regulator. So we're going to check if power supply block provide current to loads. So we're going to check if this power supply block provide voltage required by loads which are display. Because this is 5 voltage regulator that supply 5 volts to the display, which flow in this way toward display connector. We are going to check DC voltage, so multimeter must be in that mode. This one is input, and this one is output, and the middle is ground, the terminals of our regulator. If output terminal provides 5 volts toward this display connector for display to work. So let's check the output voltage of regulator. Is good. The input of regulator, which is 10 volts from step down transformer. Also input power is good, so supply block has no any fault. We have also power flow of this middle area. Let's try to check. But it has no any fault. Now let's go to the next step, number 10, which is to check the power supply in individual components. We're going to check each component present PCB so as to confirm that all components is good and they function well. And also to trace flow of current in all components by compare it with required values so as to observe where current go and where it end. If incorrect value is observed in check certain component, take out the particular component from PCB for more test or individual testing.
On power supply block which comprise transformer.
In this PCB we have already checked on power supply block which comprise transformer, regulator, rectifier and capacitor, and voltage flow is good in this block. Even in this middle parts we have already checked on some components like this regulator is good. And all capacitors are good, no one budging. Now let's move and focus on IC checking because no fault detected in other components. Now we're going in step 11, which is IC checking, so we're going to carry out IC's check. But if you're not familiar with a particular IC found in your PCB, take IC's datasheet to know input, output and all specifications. In this PCB we're going to focus with this two amplifier, one for bass and another is for tweeter speakers. In this PCB we have two amplifier which are TEO2025. Let's see how bass connected from amplifier. Negative terminal of bass, which is this white wire, is connected to this ground of IC. And positive terminal of bass is connected from these two pins connected together by capacitor. As you see in picture, so bass is connected from this left amplifier. In case of tweeters, the right side tweeter when you start it is connected here. And trace where this positive terminal is connected, the power flow from this way up to these two pins. The same left tweeter, this positive terminal is connected from this way up to this connection. So the left amplifier is for all left and right tweeters. Check all these IC amplifiers by using multimeter and amplifier pin diagram by checking output provided by amplifier to the speakers. This one is pin diagram for all these two amplifiers. This one here is input pin. This out 1. And this is boost 1 pin. So the speaker is connected to the amplifier as this manner, positive terminal move 2 pin which are out 1 and boost 1. All can be out 2 and boost 2, and negative terminal connected to the ground pins. This is how bass and tweeters are connected. So by using multimeter, let's check if power comes from 1 boost 1 and out 2 and boost 2 of amplifier is power enough for our speaker to work. Negative terminal of multimeter on ground. No power from out 1. The same boost 1, no power. And for out 2 and boost 2 is same, no power also. Let's check also this IC, no power in all 4 pins. But input power reached to the amplifier, which is 10 volts through this versus positive pin. So input voltage get into amplifier, which is 10.61 volts. There are no any power come out in all pins of amplifier required to be connected to the speakers. So we can conclude that both amplifiers have faults that you can remove out of PCB for more checking by using IC's testers to be more accurate. So no power that come out to make speaker to sound because the power that come from this 2 pins out and boost of amplifier pass to capacitor for filter some noise and certain frequencies enter speakers. Now we are going to remove these amplifiers and replace them with equivalent amplifiers and check again power if will come out from all pins required the speaker to works. Hello friend, I am already replaced these damaged amplifier with their equivalents. These are removed amplifiers. As you see. Let's use multimeter again to check if power come out from amplifier pins so as to verify that subwoofer can work now. These 2 wire for bass because bass connector is shaking, so I am connecting here at this time. So let's start with bass negative multimeter terminal on ground. When you check the out one has 5 volts. And boost one has 10.46 volts. And input is 10.61 volts at versus positive pin. When you check again, ground is here. Ground is here. Boost one has 10.49 volts. Out one has 5.13 volts. And plus versus is 10.61. Will be the same to boost 2 and out 2. Now let's check the tweeter connection in right amplifier. Boost 1 has 10.49 volts. Out 2 has 5.20 volts. Plus versus has 10.61 volts. Will be the same for boost 2 and out 2. So now our subwoofer can be used again because all sounds are good. I mean it has sound now. Let's turn on it to see if it has sound now.
FM tenure. Line in.
This is how to troubleshoot subwoofer.